Okay guys, this is section 2.3. Our goal here in this section is to be able to graph linear equations in slope-intercept or standard form. A little bit of vocab. A parent function is the most basic function in a family of functions. What we're going to look at in this section is the parent function of a linear equation or a line. So, to kind of rough sketch it, the parent function of a linear equation is just y equals x. It has a slope of 1/1, and it goes through the origin, where it has a y-intercept of 0. Which brings us to y-intercept. The y-intercept is the coordinate of a point where a graph intersects the y-axis. So it meets or touches the y-axis at a specific point. In slope-intercept form is a linear equation written in the form y equals mx plus b. I'm sure you guys have heard that before, where m is the slope and b is the y-intercept of the equation's graph. So, there's a couple steps of how we're going to use slope-intercept form to graph an equation. That first step is to be able to write the equation in slope-intercept form. Then we're going to identify the y-intercept and plot on the y-axis. So we're identifying the y-intercept and then graphing it on the y-axis. Step 3 says, okay, now identify the slope and use it to plot a second point on the line. And then step 4, we're drawing the line that connects those 2 points together. So with that example 1, well, we're going to graph negative 2/3 x, subtract out 1, and we said y equals mx plus b is our slope-intercept form. Well, it already looks like slope-intercept form because y is all by itself on the left. We have an x term, and we have a y-intercept b. So what I'm going to do now, though, is pick out my slope and pick out my y-intercept. So m in this case is always attached to x, so my slope's always attached to x. In this case, that's negative 2/3. And then my y-intercept is always attached on the end. So in this case, it's negative 1. So what I always recommend you guys to do is graph your y-intercept first. So at negative 1, it crosses the y-axis. Then use your slope at that point. So using that point at the y-axis or your y-intercept, you need to go down 2 to the right 3. Down 2 more to the right 3. And you can keep doing that until you run out of room on your coordinate grid. You could also go up 2 to the left 3. Okay, so then the last step here, connect them, and you're done. Okay. Standard form is just a linear equation written in the form ax plus by equals c, where a and b are not both 0. So a and b and c, they're just regular old numbers. And it just happens that the x term and the y term are both on the left side, and then c, a regular old number, is on the right side. And an x-intercept, the x-coordinate of a point where a graph intersects the x-axis. So we have both an x-intercept and a y-intercept. X-intercept crosses the x-axis, the y-intercept crosses the y-axis. So in example 2, how we're going to graph this one is using our x and y intercepts. So what I'm going to do here is write x-intercept and then our y-intercept. Okay, to find the x-intercept, we're going to plug 0 in for y. Okay, so let's do that. So 5x stays the same. I'm plugging 0 in for y from my original equation. Still equals 10. Well, 2 times 0, that's 0, so it goes away. So I'm left with 5x equals 10. And to get x, I just need to divide. So x here will be 2. But I want this as a point because these are intercepts on the graph. So if I make this a point, x term always goes first, or x value. So that's 2. And then the y value we plugged in was 0. So 2, 0. That's our x-intercept. I can graph that. Now if we want the y-intercept, I'm plugging 0 in for x now. So instead of 5x, it's 5 times 0 plus 2y, that stays the same, equals 10. Well, 5 times 0, that's 0. It goes away. So I'm left with 2y equals 10. And to get rid of that 2y, I need to divide by 2. So y is 5. But again, these are points on the graph. If I always use the xy as point, or an ordered pair, well, 0 was the x value that we plugged in, and we got back out 5 for the y value. So I can graph 0, 5. Okay, so here is our line that we connect. Okay, so this one was in standard form. We found the x-intercept and the y-intercept. So if it is in standard form, most of the time you would want to find the x and y-intercepts instead of moving things around and making it look like slope-intercept form. In our last example here, we have to graph y equals 2 and graph x equals negative 3. Okay, so y equals 2, there's no slope. Okay, since there's no slope, we said that's 0 slope. And from section 2, we said, well, 0 slope, that's a horizontal line. So I can graph 2 on the y-axis and make that a horizontal line. And there I have it graphed. But x equals negative 3, okay, well, if I find the x-axis, I'm plotting it on negative 3. If I were to make that horizontal, that would be my x-axis, and that's not right. Okay, so with x values on the graph, these are vertical lines. And we said back in section 2, well, if we have a vertical line, these are called undefined. They have an undefined slope. Okay, so that's how you would graph y equals something and just regular old x equals something.